Hello and Assalamu alaikum. My name is Daiyan Khan. Today, me and my group are going to be presenting a summary of a paper named An Adaptive Synchronous Parallel Strategy for Distributed Machine Learning. So, what is distributed machine learning? The current state of big data has been leaving us with very complex machine learning models as well as increased volumes of data that need to be parsed by the models. And single computational nodes are not able to handle the load themselves. And thus, distributed systems are currently being used to train large-scale machine learning models. Currently, there are three mainly used distributed machine learning systems, and they are parameter server frameworks, bulk synchronous parallels, and stale synchronous parallels. So as you can see, parameter server frameworks are currently on their third generation of improvement. The first generation connected nodes and memory caches that could communicate with each other and access global parameters, but this was a simple concept that was not optimized for machine learning. The second generation severed connections between the nodes, allowing only the parameter server to communicate with the nodes. And the third and current generation is the most advanced at the moment. Here, separate servers contain the global parameters and the servers can communicate with each other. Here, server managers control the servers and task schedulers control the nodes, but it does not account for external disturbances. So moving to how the bulk synchronous parallel works. Every node is stopped at a synchronization barrier after one iteration where it uploads all of its parameters, and it has to wait until all nodes finish one iteration. This is a system that is limited by the computational power of the least powerful node.
Assalamu alaikum, sir. I am Md Mamun-Or-Rashid. My ID is 211660005. Now I am going to describe the part still synchronous parallel. To overcome the drawbacks of BSP, we proposed SSP. Due to the iterative convergence nature of most ML algorithms, SSP does not use a synchronized barrier immediately after an iteration. Therefore, the computational nodes can perform the next iteration directly instead of waiting for other computational nodes to finish. It only synchronizes all computational nodes when the fastest computational node exceeds the slowest computational node by S iteration. Here, S is called the stale threshold. For distributed ML algorithms, SSP yields faster training efficiency and convergence. We use SSP to propose a parameter server framework for distributed ML improves this framework so that it can be used in distributed GPUs. We set 5 computational nodes to perform the training of the distributed ML model. As illustrated in this first figure, the axis shows the number of iterations for which the computational nodes train after a synchronization barrier. We found that each computational node has similar performance. In this second figure, the axis shows the number of iterations for which the computational nodes train after each synchronization barrier. If the difference in the number of iterations between computational node 1 and 3 is more than 5, more than S, computational node 1 will enter the synchronizations barrier to wait for the other computational nodes to finish their iterations. Dynamic communication strategy. In this section, we first introduced the theoretical analysis of ASP. Most of the ML programs have an iterative convergent nature and can be expressed as this equation. Here, L is the total number of samples in the dataset. Xi, Yi is one of the samples in the dataset. Yi is only appears in the marked dataset. And M is the ML model. The program uses the data samples to feed the ML model through constant iteration. And this is the final formula which describes the ML model that is obtained by using ASP. We can establish that ASP converges and provides correctness guarantees.
Assalamu alaikum. I am Sanowar. Let's discuss about performance monitoring model. To realize the dynamic adjustment of parameter communication, This paper implements performance monitoring model. The model takes advantage of the open source distributed monitoring system Ganglia to obtain the performance information of each computational node, including the CPU utilization, memory utilization, hard disk utilization, input-output load, and network traffic. So our third and last part of dynamic communication strategy is ASP, which generalizes and improves upon SSP. You can see the flowchart of the strategy here. They take a computational node and a parameter server as an example. Then the computational node starts iterating. The Gmod will monitor the performance of the computational node, and the parameter server will extract the performance data of each computational node and compare their CPU occupancy rates. Then the parameter server will adjust the stale threshold S. The parameter server will judge whether the number of iteration of the computational node satisfied the stale threshold S and the weak threshold W. If the number of iteration reach the condition of the synchronization barrier, the flag will be set to 1 and sent to all computational nodes. However, if the condition of the synchronization barrier is not reached, the computational node does not need to enter the synchronization barrier. Therefore, in this case, the training is carried out directly with the stale model to improve the training efficiency of the model. This is how the ASP flowchart works, and this is the end of the dynamic communication strategy section.
Assalamu alaikum everyone, I'm Mamun-Or-Rashid Shahriar. So in this paper the authors set up a specific environment for their training dataset and test datasets. So this particular framework, particular environment is built on a distributed deep learning framework that is based on CAFE. So CAFE is a deep learning framework that specifically works on parallel computing and speed, and so they choose CAFE. Here they implemented CAFE on ASP and also a parameter server. So as we can see from the figure here, so as they can see from the figure here, the global parameter storage function, the communication static function, and resource allocation scheduler. These are the three primary nodes of the parameter server, and it's using asynchronous data sending for uploading the gradient and global model parameters. From this paper we can see that they have some specific computing process for the computational nodes, and each one of those has a corresponding PO-SIX thread, so the parameter server, which is responsible for communicating information through the nodes. Then they have set up one more communication strategy that executes that strategy execution judges whether the computational nodes need to enter the synchronization barrier according to the parameters. The communication between the parameter server and the computational nodes is executed by MPICH, which is asynchronous uploading of the gradient process, and the global model parameters are sent to the computational nodes for proper sequence. For this experiment, they specifically used 4 nodes connected with Gigabit Ethernet. Each node is configured with 16 core AMD processor and 32 GB of RAM, and they're running on CentOS. For the effectiveness and performance of ASP, we can see for the model was trained on a specific dataset of 60,000 data, and 40,000 of those were used as train dataset, and 10,000 were used as test datasets. Um, so when the model reaches like 5,000 iteration, this experience some interface programming, so that we can, I mean, they can track the computational performance. So as we can see from the first graph here, the accuracy is dropping with the computational power is as this progresses, because the number of processes increasing, first graph. And there is a fact that is the communication between the computational nodes and parameter server and training. Sorry. However, the training time does not decrease literally as the number of compute process increases, but it doesn't go beyond a certain threshold. As you can see here, it like paralyzes and stays up, not going down for for a long time. So from these two things, we can get that this distributed machine learning model with ASP reduces training time significantly, and as well it's ensuring uh, a certain level of accuracy. In this case, it's not dropping below a certain level. From this analysis, we can say that this this framework they built is performing pretty good through this strategy they built, and it can achieve good performance. That's all from me now. Thank you.
Assalamu alaikum. My name is Redwanuzzaman, ID 211660001. Extensibility of the ASP strategy. Our group 4 nodes apply the MF framework 10 distribution ML model. And there are one node as a parameter server and the other as communicational nodes. And this maintain balance the training process are evenly distributed among three computational nodes, and there are set of value s to 1 2 and 3 in ssp and asp dynamically adjust the value of s in both strategies. This time of we set the value of w to 1, and there are the other of terms are the same as in paragraph 4.2. Specific result can be figure 13 and 14 show. And this figure 13 and 14, this figure 13 is based on accuracy ML model, and the ASP 14 14 figure based on training time of ML model. And this ML model 13 and 14 figure of accuracy and training model after adding node in vigorously the same as reported in session 4.2, and the accuracy decrease as the number of processes increase. And this addition model training with ASP require less training time, and incorrect inconstant SSPS with a delivered threshold of 1 require a lot of time training time. And this conclusion part of our paper, this time of training of ML model delivered with ASSP can reduce communication and synchronization cost and improve the use rate of and computational efficiency of communicational nodes. And we propose the new communication strategy called ASP, which adds a worker threshold and dynamically adjusts the stay threshold and improves performance based on the monitoring data obtained by Ganglia to balance training time and model accuracy. This distributed ML algorithm and the experimental results show the ASP can guarantee better accuracy and achieve higher convergence spaced the then SSP and HAS better extendability. And thank you. Assalamu alaikum.